Good morning to one and all. In the in this today's video lecture series of casting process, now we are going to discuss about one of the type of casting, that means shell molding or shell casting. What is shell casting? It is a type of metal casting process which is similar to that of the sand casting, in that molten metal is poured into an expandable sand-based mold. However, in shell mold casting, the mold is a thin-walled shell created by applying a sand-resin mixture around a pattern. Here, the molding sand is mixed with the resin and then it is used to create the pattern. The pattern, a metal piece in the shape of the desired part, is reused to form the multiple shell molds. A reusable pattern allows for higher production rates, while the disposable molds enable complex geometries to the cast. Compared to sand casting, this process has better dimensional accuracy, a higher productivity rate, and lower labor requirements. It is often used for small to medium parts that require higher precision. Where higher precision is required, this type of casting process can be used. In this type, it is used for both ferrous and non-ferrous metals. The most commonly used metals are cast iron, carbon steel, alloy steel, stainless steel, aluminum alloys, and copper alloys, etc. Typically, different types of parts from small to medium can be produced with the help of shell molding with a great accuracy. Some of the examples are gear housing, cylinder heads, connecting rods, lever arms, etc. This is the step-by-step procedure of shell molding. The first step is this is the pattern, and this is the dump box. Here the sand is filled with the resin binder. Here the pattern is heated up to a certain temperature in the microwave oven. This is the first step. Second step is we need to tilt the dump box in the opposite direction, so the sand with the resin binder falls on the heated pattern. Here the sand with the resin mixture, as it is then heated pattern, the resin with the sand mixture get sticked into the pattern wall like this. Again, this box gets into the vertical inverted position, and the sticked resin particles with the sand mixture get sticked into the heated pattern. After that, the pattern is removed and it is kept in the microwave oven for further hardening, and then the shell molding is removed and the other part is removed with the help of the sand box. This is the final step. Here the two patterns are coupled together with the help of the clamp, and a molten metal is poured into the cavity to produce the cast particles. We will explain in detail. First step is a two-piece metal pattern is created in the shape of the desired part, typically from iron or steel. Other materials such as aluminum can also be produced with the help of the process. First is the mold creation. Each pattern of is heated to a certain temperature, that means 175 degrees Celsius to 370 degrees Celsius, and coated with the lubricant to facilitate the removal. The heated pattern is clamped to the dump box, which contains a mixture of fine silica sand and a thermostatic phenolic resin binder. The dump box is inverted, allowing the sand and resin mixture to coat the pattern. The heated pattern partially cures the mixture, which forms a shell around the pattern. Depending upon the time and the temperature of the pattern, the thickness of the shell is of around 10 to 20 mm thickness. Each pattern top and the surrounding shell is cured to completion in an oven, giving it a tensile strength of about 350 to 450 psi. That means 2.4 megapascal to 3.1 megapascal, and then the shell is ejected from the pattern. Next step is the assembly of mold. The two shell halves are joined together and securely clamped to form the complete shell mold as it is shown in the figure. If any cores are required, they are inserted prior to the closing mold. Then the shell mold is then placed into the flask and supported by the backing material. Next step is the pouring of the molten metal. The mold is securely clamped together while molten metal is poured from the ladle into the gating system to fill the mold cavity. Further cooling process carried out. After the mold has been filled, the molten metal is allowed to cool and solidify in order to get the desired casting. Finally, the casting removal. After the molten metal has been cooled, the mold can be broken and the casting is removed. Then trimming and cleaning process are required to remove any excess metal from the feed system and any sand remaining from the mold. Some of the applications of shell molding are: in case of aerospace components, shell casting is used for creating complex and high precision components in the aerospace industry, such as turbine blades. Next, for jewelry applications, file jewelry is often made using a similar process, especially for intricate designs. And then in case of automobile companies, engine components and other critical parts can be produced with the help of the shell casting. Thank you.